Hello, everyone. Welcome to my talk on Jenkins X. So let's get started. So before we dive into Jenkins X, I just want to step back a little bit and just talk about the software industry. So the last 5 years, it feels like more things have happened in software and what it means to build, develop, test, deploy, manage software. That all seems to have completely changed. So the move to the public cloud is quite a big change. Increasingly, we're all using more and more public cloud because it's elastic. You don't have to guess how much hardware you're going to need next year and buy machines and buy office spaces to make data centers. You can just rent and pay this month for what you used last month, kind of thing. So the move to the public cloud is a big deal. A lot of us are moving there. There's also a huge move away from virtual machines to containers, mostly because of cost. Containers typically cost about 20% less than virtual machines because they're smaller, right? If you're trying to run, say, 3 Java microservices on a machine, if you use virtual machines, you're running 3 copies of Linux, 3 device drivers and schedulers and operating systems and network stacks and all that kind of stuff. If you use containers, you're running 3 processes, right? So containers are cheaper than VMs, so we all need to move to containers to save money. Then as soon as you move to containers, you've now got this problem, how do we run all these containers? How do we manage them and operate them? And that's where a thing called Kubernetes comes in. Kubernetes started about 4 years ago. It came out of Google. Google have been running containers at scale for over a decade now. Pretty much everything at Google runs in a container. So whenever you do a Google search, or you use Google Docs or Google Maps, everything is running in a container in Google's data centers. So what Google did was basically create an open source project based around how they manage containers at scale, Kubernetes. Since they open sourced it about 4 years ago, loads and loads of people have joined the community. It's pretty much one of the most active open source projects on the planet today. It's a really awesome, amazing product. It's my favorite open source project, so please check out Kubernetes. It's totally awesome. And I think 2018 is the year that Kubernetes officially won the cloud war. Every cloud vendor now has a managed Kubernetes service as an offering, right? So whether you use Amazon, Google, Microsoft, Alibaba, DigitalOcean, pretty much every cloud provider now has a managed Kubernetes service. Now, friends don't let friends install Kubernetes, right? Kubernetes is an amazing piece of software, but you should never really try and install it and manage it yourself. So I highly recommend, if you're going to try Kubernetes at all, use a managed service from a public cloud, right? Use Google or Amazon or Microsoft. All 3 of them have a little web console that you say, please create me a Kubernetes cluster, and it creates one for you. But the most important thing is, well, firstly, it works. And the other thing that's important is that cloud provider will manage that cluster for you. So if a node dies, it will automatically restart. You can scale the cluster up and down. You can scale it to 0 if you want and scale it back up to 1,000 nodes if you wish. So if you're looking at Kubernetes, I highly recommend look at the public cloud. It's the simplest way of using Kubernetes because it is a challenge to install and manage your own Kubernetes cluster. It's technically possible, but it's much easier to use a managed cloud. So the move to containers, the move to the cloud, the move to Kubernetes all changes everything from a technology perspective. There's another movement in the software industry right now, which is the whole how should we build software value effectively and quickly. So things like microservices, the State of DevOps report and the Accelerate book all talk about how should we build software so that we deliver business value to our customers quickly. And it's really all around doing small increments of code and getting that code in front of real users as quickly as possible. So microservices helps us go faster because you're working on smaller pieces of code each time rather than big, huge monoliths, right? The bigger the code base and the bigger the monolith, the harder it is to change, the riskier it is to make a change, and the slower releases become. So the move to microservices and the move to high-performing teams means we're doing lots of little bits of code and getting them in front of users as quickly as possible so that we get feedback. So all of these different things has made it increasingly challenging to be a high-performing team. So if we're all trying to be high-performing teams now so we can deliver business value to our customers, we need to figure out all this stuff. So we need to figure out how do we set up a cloud? How do we set up multiple Kubernetes clusters for environments? How do we move everything to containers? How do we deploy on Kubernetes? Do we write Kubernetes YAML? Do we use something called Helm? Then we need to figure out how do we do continuous delivery on Kubernetes with containers and with Kubernetes. And then there's a thing called GitOps, which has become very cool and trendy these days. The Weaveworks folks coined this term GitOps, which is basically when you're doing operational things like managing stuff in a staging environment or managing things in production, put all of that configuration stuff in a Git repository so that you can manage operational configuration, just like we manage source code for applications by using source control, right? So we can check in all of the configuration into Git. So then if all of a sudden production goes down, you can see who did the last commit on the production repository, so you can always just revert it, right? So Git is a wonderful tool for source control. So we need to figure out all of those different things. Then we need to figure out how to get feedback loops going so that our promotion through GitOps, we get feedback. And then finally, you need to actually write your application. So there's a whole heap of problems to figure out these days if you want to be a high-performing team and use things like containers and Kubernetes. So luckily, there's a tool that will help you. Your naval butler will come and help you sail the seas of continuous delivery. And that's really what Jenkins X is doing. So Jenkins X is a relatively new open source project. It was announced this year. It's a proposed sub-project in the Jenkins Foundation. And Jenkins X is really trying to help people automate the continuous delivery on Kubernetes so that as developers, you can just focus on building your application and you don't have to worry quite so much about all of this container and Kubernetes and CD and GitOps and all those kind of things. So it's really trying to do continuous delivery as a service, effectively, on any Kubernetes cluster. So how does Jenkins X help? So the first thing Jenkins X does is integrate a whole bunch of different open source tools to help you do continuous delivery. So the Kubernetes ecosystem is huge and diverse and awesome, and there's amazing technologies and tools being built within the Kubernetes ecosystem. But it can be a challenge to keep track of everything that's happening in Kubernetes and to figure out what tools should you use in the Kubernetes ecosystem. So one thing Jenkins X does is it picks all of the best of breed technologies to put together the tools you need to do continuous delivery on Kubernetes. So there's tools like Helm, which is a package manager, which is amazing and is mostly maintained by Microsoft these days. There's a tool called Scaffold with a K, which is from Google, which helps you build Docker images using various different technologies under the covers on Kubernetes or using Google Container Builder or something called Canico. Then there's various other pieces like Monocular, which is like an app store for Kubernetes where you can put your apps in there that your team members and other people in your organization can easily share those applications and so forth. So there's a whole range of different open source tools that Jenkins X integrates together and installs for you. So you just install Jenkins X and it manages all of these different pieces of software. So that's kind of cool. But the other thing Jenkins X does is it automates the CI and CD for your actual applications. So you can just create a brand new application, I'll show you in a few minutes. You can just create a new application from scratch and it will automate all of the CI and CD for you. So you can just focus on what you should be doing, building business value for your customers, and you don't have to quite worry so much about all the CI/CD bit for you. In addition, Jenkins X also generates the Docker images for you. It generates the Helm packages, which is the package manager thingy, and it generates the CI and CD pipelines. It also automates promotion between environments, so to go from testing to staging to production. It automates that promotion for you using GitOps under the covers. And also it does lots of feedback. You'll see the feedback in a few moments. So that all sounds kind of cool. So how do you get started with Jenkins X? So the first thing you'll need is a command line tool called JX, JX for Jenkins X. So JX is a little binary. You can click on that URL and download it, or go to the Jenkins X website and click to download the binary. If you're on a Mac, you can use Brew to install it. If you're on Linux, you can use curl, or you can literally just download it from GitHub and put it in your path. So you first need the Jenkins X binary. Then the next thing you need to do is set up a Kubernetes cluster with Jenkins X installed onto it. The thing we recommend, which is the easiest way of going, is the JX create cluster command. So the first command on this slide. After you've typed JX create cluster, you then need to type which kind of cluster do you want to create. So do you want to use GKE for Google Cloud? Do you want to use AKS for Azure? Do you want to use AWS for Amazon, which is currently using COPS? Fairly soon we'll have an EKS command to use EKS, which is the new recently announced managed Kubernetes service from Amazon. You can use things like Minikube and stuff like that, but we really recommend please use the public cloud. It's much better. If you're using Minikube, you don't get any webhooks because GitHub can't see your laptop. So Minikube isn't really recommended. A lot of people struggle to get Minikube even working. Everything works on the public cloud, so I highly recommend just try the public cloud. They've all got a free tier, so you can just try it for a day and then tear it all down and you won't be billed. If someone's already created a Kubernetes cluster for you at work and you have to use it, then use JX install. So JX install just installs Jenkins X onto a Kubernetes cluster. So use one of those two options. We prefer the create cluster option, but use either. Here's a quick demo. I won't sit you through a live demo of installing Jenkins X because it's not the most interesting thing to watch in the world. But here's a very quick demo, hopefully, maybe, if the internet's working. Maybe the internet's not working. It's going to be a good live demo if the internet's not working. Okay, never mind. I'll try that one more time. Yay, it's working. Okay, yay. So you basically type JX create cluster, and then it asks you for which region and what kind of node you want to use. Then it installs something called an ingress for like a load balancer thingy. Then it installs Jenkins X. Then the very last thing it does is it prompts you to create 2 Git repositories, which I'll talk a little bit about later. That's for the GitOps. So the whole thing, this is slightly speeded up. There you go, and it's just about installed. Then it's going to create 2 Git repositories. There we go, that's one repository, and then there's a second one. So the whole install takes, usually on Google, about 2 to 3 minutes, and then you've got a Jenkins X installed on the Kubernetes cluster. There are workshops, by the way, tomorrow. If you want to get your hands on Kubernetes and Jenkins X, there's 2 workshops tomorrow in the morning, back to back. In fact, there's 3 workshops tomorrow on Google Cloud. The very first one is purely on Jenkins X. Then there's another one on Spring Cloud and various other bits and bobs and activity. Then there's another one on Spring Cloud and I think Istio that Ray's doing. So there's 3 workshops tomorrow if you want to get your hands on Google Cloud and Jenkins X. So come along to those. So what does the install give you? Once you've installed Jenkins X, what do you get? So the first thing you get is a development environment where all of the tools run. So there's a Jenkins master in there, and a whole bunch of other tools to do CI and CD. If ever you use Jenkins at your company, you might have a Jenkins with like every single build that everybody in your organization has. In Jenkins X, each team gets their own Jenkins master, so each team sees just their team's builds, right? And each team has an elastic pool of build pods, so that you don't have to wait for all these other teams to do their builds first before your builds can trigger, right? So each team gets their own Jenkins, which is cool. Each team also gets their own staging environment and production environment. So that means each team can immediately roll out changes to staging without having to wait for other teams, without having to get sign-off or go to meetings and various other things. So you can go fast and deliver value. Out of the box, Jenkins X is configured to have 2 environments by default for each team, staging and production. And we've configured staging to be automatic, so every time you merge to master, a release is promoted to staging. And we've set up production as requiring a manual release, so you have to manually promote to production. Now, we hope everyone will eventually automate production as well and flip it from manual to automatic. But we kind of figure it's going to take a little while for most people to feel confident enough for every change to go straight to production. But the idea is to hopefully help you do that leap. So without further ado, let's actually do a live demo on the conference Wi-Fi on Google Cloud. So what could possibly go wrong? Right, so let me just check the internet's working. JX get env. Yes. Phew. Okay, cool. So the internet's working. That's good to see. So JX is a command line. It's rather like Git. It's got a whole bunch of subcommands that do all kinds of different things. JX get env lists all the environments that are in my team. So you can see I've got a development environment, I've got a personal environment, Strachan, and then I've got staging and production. And you'll see there's the Git URL of where those repositories live. So what I'm going to do, I'm going to create a new application. Let's clear this window. So we have a command JX create Spring, which uses the Spring. If ever you've used Spring, there's the start.spring.io website, or I think it's called the Spring Boot Initializer thing. This is basically a JX command line facade over that same thing. So we're using the Spring initializer to initialize a project. We get to pick what language do we wish to use. Let's go with Java. What should we call a group ID? That looks okay to me. What should we call the demo? We call it BCN cool. And then we're going to pick which dependencies do we wish to use in our Spring Boot application. So let's go for actuator and let's search for web. Let's go for web as well, hit spacebar. So now it's creating the source code on my laptop. Now it's going to asking me, should we initialize a Git repository? Yes, please. Yeah, let's initialize. So those are all the files that have been created by the Spring Boot initializer. So it's just some Java code and a POM, and that's pretty much it. It's going to import that into Git for us. Now it's going to run the build pack, which is where it's going to look at all the source code and figure out what does it need to do CI and CD. I'll talk about the files it's created in a moment, but you can see it's created a bunch of files. Now it's pushing this up onto GitHub, and fingers crossed, GitHub works. So far, so good. Yay, it worked. Woo. So we've created a new project, and if I copy and paste this line, that's going to watch the pipelines running. I'll leave that running in the background, and I'll show you some other stuff in the meantime. So I typed one command, and let me just click on that URL. So this is the project we've just created on github.com. Make that a bit bigger. So it's a normal project on github.com, and it's checked in all the source code here. So you can see the normal, Java stuff's in here. Usual Spring Boot stuff. There's some Java code. There we go. Also notice it created a bunch of other files. So it's created a Docker file. The Docker file is the thing that turns the jar into a Docker image so you can run it on a container platform, bless you. There's a Jenkins file, which is the thing that does CI and CD, that does the pipeline stuff. There's a scaffold thing, which is how it builds a Docker image. And then there's this charts folder, which contains bless you again. There's this charts folder that contains all the various Helm YAML for deploying on Kubernetes. So the build pack has added all these different files into Git for us. We don't need to look at those or even know or care that they're there, but it's important to remember that in Jenkins X, we're not hiding anything. If you ever need to tweak the Docker file or you ever need to tweak the Helm charts or you want to do something special in your pipeline, you can just edit the files. Everything's in Git. So you can just go into Git, edit the files, and commit, and you're good to go. Right, one other thing, if I click on the Releases tab, you see we've just tagged the code. We haven't quite finished the pipeline yet. So just to recap what's just happened, I typed one command, JX create Spring. It's created a new Spring microservice, and it's set up the CI and CD pipeline, and it's already releasing a build, a release of that, and then it's going to promote that to the staging environment. Now, why do we do that? So what we're trying to do is encourage developers to do the right thing from day one. So rather than having a whole bunch of source code and hacking away on the laptops for a few weeks, and then thinking, let's try and run this in Kubernetes now, and then going through that learning curve of trying to get it to work in Kubernetes, we're trying to flip it around the other way and immediately run everything on Kubernetes and keep it running, and run everything all the time on Kubernetes so you don't hit that wall of suddenly having to figure out what change should I do that broke it from running on Kubernetes, right? So we're trying to go to Kubernetes first, and then from there do incremental changes while always testing everything works on Kubernetes. As developers, we always tend to run things on our laptops as developers, which is kind of okay, but it's kind of crappy because we're testing things on, say, a Mac or a Linux, or possibly a Linux box or a Windows machine. It's going to be a different operating system, different networking stack. It's not going to be a container. Everything's going to be different. We should always try and run things on the production cluster as much as possible, because then we're testing what's really going to be running in production rather than what's running on your laptop. So we highly recommend running in Kubernetes as often as possible. So if I just hit reload, you can see we've done a 001 release. So what the pipeline has done is it's tagged Git with 001. It's generated the release number 001, tagged Git. It's deployed the POM and the jar into Nexus with the 001 release version. It's tagged Git, obviously, with a branch. It's generated a change log. It's now made 001 Docker image of the application, pushed that into a Docker registry. It's created a 001 Helm chart and put that into the App Store. And now it's doing a promotion. If you see this line here, you see pull request, and it's got a URL here. If I click on that, so we've created the 001 release, and now it's going to promote that release into staging using a pull request. And this is where the GitOps piece comes in. So we do promotion by doing a pull request on the Git repository for the environment. So you see this Git repository here. This is the Git repository for my staging environment. And we've created a pull request. And that pull request, if I look at the diff of the pull request, that pull request is changing 3 lines of a piece of YAML. Now, it doesn't matter what this file is. Don't worry too much about the detail. But basically, we use a YAML file to define all of the applications that are deployed in that environment. So because we've never deployed this app before, it's adding 3 lines, which is the name of the app, the repository that the Helm chart lives in, and the version number of the Helm chart. So the first time we deploy an app from scratch, we have 3 lines to change. And then the next time we do a release, it will just change 1 line, which is just the version number. So usually when you do a promotion, you're just changing version numbers, right? So it's a simple, small pull request. It's easy to review and look and understand. It's not weird. And so that pull request has now been merged, actually. There we go. You see it's been merged. If I go back and hit refresh on the browser. There we go. So it's merged. So the pull request was created. Then a CI job has run on that pull request to check Is the Helm chart valid? Is the Docker image valid? Does it compile and everything? Is it a valid-looking pull request? Now they put the CI job passed, so that went green, so then the pull request merged. And now there's another job now running, which is going to apply that version of the Helm chart into the staging environment. So in a few moments, it will eventually, hopefully, be promoted. There we go. It's now running the update job of that version, and in the next minute or so, we should have that application in staging. Now, that sounds a bit of a mouthful, but what we're trying to do is encourage everyone to do things the right way for production, right? Every code change you do, you create a new unique version whenever you merge to master, and then you promote that version through all the environments you need to go through, right? Testing, staging, production, and the promotion is automated for you via GitOps. So at any point in time, you can edit the Git repository to go back a version, to go back 3 versions, to go forwards and backwards and so forth. It's all just simple Git. Now, the other advantage of using GitOps is it means all of the configuration for the staging environment and all of the configuration for the production environment is all in the Git repository. So you can manage operational tooling like Prometheus or Elasticsearch or whatever kind of operational tools you wish to use. You can manage those in the same way as you're managing your actual applications. You can also manage all of the config of all the various things. So you might configure, for example, in production, you might want to run 20 replicas of your app. In staging, you might want to run 5. So those configurations of scaling can all be in Git and managed operationally through GitOps. So phew, the promotion worked, that's good. So now we've got a running app in the staging environment. So if I click on it, there we go. So that's the application running in staging. That might not look terribly impressive, but that's the standard out-of-the-box Spring Boot web console. So there's the application. We typed one command on the command line, JX create Spring, and we've created a new app. We've set up CI and CD, and we've automated the release, and we've promoted it through GitOps into the staging environment. So now I want to quickly show you how to actually make a code change. So if I go into this app source code, BCN cool, so this is all the source code that I just created. Oops, my spacebar's being wonky today. This is always good. I don't like this new keyboard on the Mac. Okay, so let's make a code change. So I'm going to copy a magic file I happen to have on my laptop to save my typing. Desktop fix man to source. If I do git status, there we go. I'll do git add. So I'm going to do everything just through the git CLI, just to show you that I'm not doing anything sneaky or weird. So git add, git status. Yeah, we've added a file. So, let's create a new issue, actually. We'll do JX create issue. Fix better home page. I'll just say better home page. So we'll create a new issue. There we go. So that's created a new issue on GitHub for us, which we can look at. There we go. That's a quick way of creating a new issue on GitHub. Now we'll do a git branch. Come on, keyboard, you can do it. There we go. Branch cheese. Git checkout cheese. There we go. Now we'll do a git commit. Minus A, minus M. Fix homepage. And we'll say fix, new line first, and then fixes #1. There we go, and a git push. So notice now I'm just doing git stuff, right? I'm not doing anything weird or wonderful. I'm not using any kind of magic Jenkins X stuff. I'm just doing vanilla git stuff. And if I click on the home page, you'll see GitHub says, would you like to create a pull request? And we say, oh, yes, please. And we say, create pull request. So we're just doing git stuff, right? It's pure git. We could use our IDs for this. We've created a code change in a pull request and submitted a pull request. Now GitHub should hopefully, you see GitHub's updated to say that there's a CI job running now. You see that there? So it's important to remember we've got CI and CD all integrated together. So whenever you submit a pull request, we automatically do the normal continuous integration type thing to check, does all the code pass, does it compile, do all the tests run, whatever your quality checks or test checks, all those have to pass before a pull request can be merged. So the pull request pipeline is now going to chug along for a while. You'll see this terminal over here, by the way. It's appearing in here, so we can watch the pull request pipeline run there too. So what we do is we do the CI and the CD. So the idea is we keep master clean and releasable at all times. To make a change, we want you to do a pull request first. Then we can validate the pull request is valid and works and runs in Kubernetes. Then when that passes, you can merge to master. When we merge to master, we then do another release. So 002 will go out, then 003. Just out of interest, I didn't mention this. We automate the generation of version numbers whenever we merge to master. And we use a little command line tool called JX to do the version numbering. JX uses Git tags on your repository to find what's the next version to use. So if ever you want to jump from, say, 001 to 100, you can just create a Git tag of 10, and then the next release will be 101 and 102 or whatever. If you use Maven, you can update your POM. In the POM, you know when you say version, and it's normally a 10 snapshot. If you edit that to 20 snapshot, the next release will start with a 2. So you can use package.json or pom.xml to manually bump up the release number if you wish, but usually it's just the next incremental release number. Longer term, we'd kind of like to automate that further to use, say, contract-based testing or Java doc or API docs or something to know, have you changed a public API, in which case it's got to be a minor release rather than a major. Or maybe if you do something backwards compatible, we could automatically force you to a major version change if you wish. So those are the versionings. So the build's chugging along. One other thing we do on pull requests is we do something called preview environments. Now, if you're building, say, a web console, just looking at a pull request from one of your colleagues and trying to do like a code review, it's sometimes hard to understand how that change is going to impact the web application, right? If somebody tinkers with a CSS file, it's kind of hard to know what that would look like. Not many of us have brains that can parse CSS and visualize it in front of our own eyes. So this idea of preview environments is whenever you do a pull request, we'll build everything and check everything compiles and tests and everything. Then we'll create a brand new Docker image for that pull request. We'll also create a preview environment, which is a Kubernetes thing. It's a namespace. Then we'll run that application in a separate namespace and comment on it. In fact, it's just happened. Comment on the issue that it's running. So you see the pull request. You see there's this new comment there. Pull request built and available in preview environment with a link there. So if I click on that link, this is the pull request running in a separate namespace. Right? Kubernetes has this thing called namespaces, which is a way of segmenting your cluster into logical clusters. So then you can create a separate namespace, and anything that runs in that namespace can't see the other namespaces. So, for example, if you're running a test, if you run a test in the test namespace, you can't accidentally connect to the production database. You only see the services within your namespace by default. So here we've spun up a new namespace to run that pull request, to test it out before we've merged to master, right? So this lets us make a change, and our team can then discuss it, look at it, try it out, run tests on it, decide if they're happy with it. When you're happy with it, you can then click the merge button. So if I go back to the pull request, it should have gone green by now. Let me hit reload. There we go. So it's gone green, which means all the tests have passed. We've tried the app out. It seems good to me, so we can hit merge. There we go. So now we've merged to master, and in a few moments now, the release 2 will go out. So 002 will start. There we go. So the next release has started. So in a few more minutes, we'll have 002 released, and that 002 will automatically promote to staging. Okay. So we've got automated CI and CD by typing one command, JX create Spring. Now, if you're not using Spring, don't worry. We have a whole bunch of different quick starts for all kinds of different programming languages. So you can type JX create quick start. And there's a whole raft of different quick starts you can use as a basis for your microservices to get started. If you already have some code already, you can type JX import. So if you're in any project folder, just type JX import. And if you haven't created a Git repository yet, it will create one. If it's already in Git, it will just use it. And if you haven't got a Docker file and you haven't got a Jenkins file, it will add those to your project and import it and set up the CI and CD. So however you wish to do your programming, whether it's in Spring Boot or Java or Node or C or whatever, Rust, Ruby, Python, Jenkins X can set up and automate all of your CI and CD for you. So I've got a little bit more time, so I'm going to show you something a little bit different now. I'll leave that release going, and then once the release has happened, I'll show you the effect of the release. While that's chugging away, I'm going to show you something a little bit different. Let's go into a different window. There we go, this one. I'm going to show you VS Code. So I'm going to switch to a Node application now. just to kind of show you that we can work with lots of different kind of stuff. So this is a very simple Node.js application that I've already imported. And as you can see, it's a very simple piece of JavaScript that serves a file called index.html, and this index.html file is, as you can see, incredibly complicated. But I want to show you something a little bit different. Well, firstly, we have a Jenkins X plugin for VS Code, so we can kind of watch all the pipelines chugging along. So we can see that this is build 2 of the demo that I just did, and we can kind of right-click and watch the build log if you wish. And this will then tail the log of the pipeline, so we'll be able to watch it downloading the internet from Maven and stuff like that, which is really exciting. And so you can watch all the build logs. This kind of saves you having to go to like the Jenkins console. You can just do everything in your IDE. We've got the same plugin for IntelliJ and for Eclipse that it's not quite released yet, but it's kind of working. So we should have fairly soon VS Code, IntelliJ, and Eclipse with all the same level of tooling. And from here, you can do things like open applications and things like that. So I can stop the pipeline, I can browse the build log and browse the pipeline on Jenkins and so forth. If I log in, we can kind of browse the log on Jenkins. So this is the underlying Jenkins that's doing everything. So you can kind of browse it in here and stuff like that. Okay, so that's the plugin, which is kind of cool. The other thing I want to show you is a lot of people, when they move to Kubernetes, setting up CI/CD is really, really awesome because it means you can just carry on working and not worrying about how releases work. But a common question people say is, well, how do I actually do development? How do I write code and try it out on Kubernetes before I'm ready to do a Git commit? So you could just create a pull request and then get that to deploy your code, but that kind of feels a bit wrong sometimes. You want to kind of try things out locally before you're ready to do a pull request. So I want to show you something that we've got that lets you do incremental development on your laptop and try things out on Kubernetes in a nice, easy way. So if I open the menu on VS Code, we have a command called open devpod terminal. So let me do that first. And that should open a new console. There we go, here. So we have a thing called dev pods in Jenkins X. Okay, let me step back and explain this a little bit. So all of the CI and CD that's running in Jenkins X is using Docker containers to run all of the various tools. So whether you're running Node or Maven or Gradle or Make or whatever build tools you're using in the pipelines, they're all running in Docker images, right? So we have Docker containers for all of the tools that are required for CI and CD. So things like Git and Maven and kubectl and Helm, and there's various different tools we use to do all of the CI and CD. So that's kind of cool, so we can manage everything and version everything consistently, so you don't have to spend time installing tools and things like that. So that's cool. However, often your developer laptop has got all sorts of random things on it. It will almost certainly have a different version of Maven, it might have a crazy different version of Git and so forth. So what we do with a dev pod is a dev pod reuses the exact same tools that the CI and CD pipelines use, but it lets you use the same tools at development. It basically gives you a shell, a terminal, so you can type on the command line whatever you wish to use. So this shell that's opened here isn't really running on my laptop. It's running in a pod inside the same Kubernetes cluster on Google Cloud. So this shell I'm in here is not on my laptop. It's actually in Google Cloud. So I can see the source code and everything. And what the dev pod does is it synchronizes the source code on my laptop into the dev pod. So it means I can use my desktop IDE, I can use Eclipse, IntelliJ, VS Code, whatever, and I can edit the source code as I normally do on my laptop, but I can run it, run the tests, run the application inside the dev pod. So it means every time I run the application, I'm running on the exact same operating system, container, cluster, DNS, load balancer, secrets. Everything's all the same as it would be in production. I'm just in a different namespace, right? There's a little magic command called watch, which if I type that in, what that's done is, you maybe didn't see it fly by, that's created a Docker image, pushed it to the Docker registry, and redeployed the application as a Helm chart. Now, I don't know if you've ever tried to do a Docker build on your laptop before. I don't have very good Wi-Fi at home. It can take like an hour to do a Docker pull and a Docker push. Pulling and pushing images is really typically slow. When you're on the public cloud, it's crazy fast because you're within the cloud and it's got an amazing network internally. So if you're within the cloud, Docker builds are really, really fast. So let me show you, I've just built the application. Now what it's going to do is it's going to watch the source code. Maybe just close that a second. If I go into JX get app, This is going to wrap horribly, but there we go. So this is the application which is now being deployed, which I can open it in my browser. So there's the application running. I'm actually going to write a curl command to curl that page. So this is just a simple shell script which is going to curl that endpoint, right, on the public internet. Now if I go back to my editor, and what I'm going to do is I'm going to make a code change. And I'll just say, awesome. And so I've edited the file on my hard drive. Did you see the build kick at the bottom? So I typed some text on my desktop IDE. It synchronized the source code into the pod that's running in Google Cloud. And then it's rebuilt, redeployed the application. And then hopefully any second now, the pod should restart. And we should see awesome. Way, awesome. So we can do incremental coding. We can type on our laptops using whatever desktop IDE you wish, synchronize the source code into the cloud and rebuild it pretty quickly. I mean, it usually takes like 5, let's say. Very awesome. Very awesome. If you watch really closely, you should see the shell rebuild it. There we go. So it's rebuilt it, pushed it, redeployed it via Helm. And then any second now, hopefully, there we go. It's taken it down because the process has terminated. Now it's going to come back up, hopefully any second now. So it's kind of like 5 to 10 seconds. Now this is the brute force thing where we're physically rebuilding a Docker image, pushing it to the Docker registry and redeploying the pod from scratch. So this is if you like, the slowest possible way of doing it. We hope to improve the round trip time. For example, in Node can watch for the file system changes and reload on the fly. So rather than rebuilding Docker images and pushing and pulling and all that stuff, we should be able to just get the app to reload on the fly a little more. We want, for Spring Boot, there's the Spring Boot dev tools. So we're hoping to use a Spring Boot dev tool. So if you are using Spring Boot, it does the kind of reload trick rather than doing the brute force. But this just shows you how you can just use the public cloud for development before you're ready to do your Git commit, right? So you can edit code live on your laptop, build it in the cloud, and then push it to the cloud and then do a rebuild and everything. So we highly recommend using the cloud for all stages of development, really. I no longer bother with Docker for Mac or running Minikube or running any of that stuff on my laptop. I do everything on the public cloud, or do everything on your Kubernetes cluster. Whether your cluster is public or on a private data center, doesn't really matter. Do everything in Kubernetes and just use your IDE and your desktop, and then you're good to go, okay? So there we go. So as a quick recap, there we go. Back to here. So a quick recap of everything we've done so far. So with one command, we can create an application, whether it's with Spring, whether it's with a quick start, or whether it's importing an existing application. That sets up all of your CI and CD. You then release automatically to staging whenever you merge to master. When you do a pull request, you get an automated preview environment that you can then test out your code changes, and when you're ready, you can merge to master, then another release kicks in, okay? And then if you want to do incremental development before you're ready to do a Git commit, you can do a dev pod, and that lets you synchronize your source code into a pod running in Kubernetes where you can do make, or you can run Maven or Maven test or whatever, or you can redeploy the application via Helm. So a few links. If you want to learn more, please visit the Jenkins X website. We've got a Slack channel on the Kubernetes Slack. If you click on the community link, there's a Slack channel where we just hang out all day. So if you ever have any questions about anything to do with Jenkins X, please go to the Slack channel and ask a question there. If you're not a Slack person, or if you have too many chat applications on your desktop and you don't want to use another one, you can always just use a GitHub issues, which are all, again, linked on the community page. So please try that out. That's awesome. Also remember, tomorrow there's workshops from 9 a.m. onwards all day. On 2 of them are Jenkins X, 1 of them's Google Cloud, 2 of them have got Spring Cloud in there as well. So there's basically a combination of GKE, Google Cloud, Jenkins X, and Spring tomorrow. So pop along to the workshop. They're all awesome. Many of the people in the first 2 rows are going to be there all day, so we'll be there all day tomorrow to come and see us. I'm here all day as well, so any more questions, just come and see me and ask a question. I've purposely left some time for questions. Does anybody have any questions on anything to do with Jenkins, Jenkins X, CI, CD? Any questions? Go for it. Whoa.
So you showed a demo with a single application, but of course
Yes.
I've got a lot of microservices in my landscape.
Yeah.
Can you reveal a little bit of how that would look like, having multiple applications in the same environment?
Yes, that's a great question. So we very much are fans of everything that the state of DevOps recommends. So things like microservices and so on and forth, and chunk-based development and those kind of things. If you're doing multiple microservices, we recommend each one ideally is in a separate Git repository. So then each microservice can be released independently. And then each one would then have its own release cycle. So you do a commit on microservice A and then do a commit the next day on microservice B. A and B would then release independently. Sometimes sometimes those microservices aren't really independent. Sometimes, say, A and B might be coupled. So if you have A and B coupled together, so you wanted to test them both together before you promote them, right? So if ever you want A and B and C to kind of be more tightly controlled together, rather than having them deploy independently, what A and B and C could do is be then combined together in a separate Helm chart. So you could have a Helm chart called ABC, which has A and B and C in it. So rather than deploying with a pull request to production or staging, you do a pull request on the chart for A, B, and C. So you can use Helm. Helm is the package manager for Kubernetes. You can use Helm to do compositions. So you can either treat A, B, and C as completely separate, or you can start building composite applications with, say, A, B, and C in them. So maybe A, B, and C are one application, and then D is separate. So you can choose how granular you wish to be. Sometimes you have a couple of microservices, and they're so tightly coupled that you want to test them collectively together before you promote. So you can do either one of those approaches. It's up to you. So on a per microservice basis, you can decide to couple them together and release that in one go, or you can do them independently. It's up to you.
Is it also possible to, on a source code level, have them separated, but
yes,
deploy them to the same namespace?
Yes. So definitely the source code should be separate, right? Some people like monorepos. We're not big fans of monorepos just because if you have a monorepo, you need to have some magic tool that figures out every Git commit, what do I actually need to re-release, right? Whereas if everything's in a separate repo, it's much simpler. You know, you change microservice A's source code, A is released, B isn't released, right? Just A. So definitely have separate source code. The way that we're using GitOps basically means you can deploy any application in any environment through the promotion. There's a command line tool, JX promote, that can promote any app at any point in time to any environment. So we've decoupled releasing from promotion. So you can promote any version of any app at any point in time. You can use the JX promote command line to promote, for example, Prometheus to your staging environment. You just need to give it an application name and where the chart lives, in which chart repository, and which version name. So the pipelines in Jenkins X automate the promotion for you. If you wish, you could do your own promotion pipelines in a different way if you want. But yes, I think does that answer your question? I think so. Yeah. Cool.
Great.
Good question.
Thanks.
What we do internally, we use something called update bot, which is so sometimes when you make a code change, like for example, you might change a base Docker image that is used by lots of other services, and you want to ripple changes through your organization. And most people do that manually by hand, right, which is a nightmare. Or, for example, a Java library. You might release a Java library, and then everyone who uses that Java library has to update their POM XML to use the new version. So we have a tool called UpdateBot, which I can kind of show you what we do. We have a tool called UpdateBot, which automates the version changes across all of our repositories. So we use Jenkins X to build Jenkins X. And this is just a quick example. These are all the pull requests that were generated by UpdateBot. So let me pick this one. What's a good one to pick? I'll do this one. This one. I'll do that pull request. If I click on that one. So this pull request was automatically generated by this tool called UpdateBot, which is included in Jenkins X, so anybody can use UpdateBot at any point in time. And what UpdateBot does is whenever you're doing a release of something, you can add an UpdateBot command to your pipeline that says, go through all of these Git repositories that I've told you about, clone them, look in them, are any of these other Git repositories using this library, this Docker image, this Java library, this node package, this whatever, and it will automatically generate pull requests on all the downstream projects. So this is kind of like CI/CD for libraries, like for not actual applications you deploy, but for libraries or Docker images or whatever. So we use Updatebot quite a lot to actively promote new versions of things downstream. When we first started to build microservices on our team, we found as we were about to do a release, we'd try the latest version of all our dependencies. And normally when you try that, everything breaks. And then you get lots of frustration because someone's changed something upstream and all my stuff's broken, and lots of anger and resentment happens. What we found with Updatebot, it's if we eagerly push changes downstream in a pull request, it means the worst case scenario is the pull request fails, but that's nice to know because the pull request has failed. Now the upstream team know that they've broken something because the pull request has failed. The downstream team know, don't manually upgrade because the pull request didn't work. So pull requests between projects is a really nice way of communicating the change and automating the change. And then both sides, both teams understand what's going on. And ideally, what we want to be doing pull requests across all of our projects all the time, right? We want to be doing this to upgrade Spring versions and Camel versions and all the Java libraries we use and the Maven plugins and whatnot. So we want to automate more and more with Updatebot because it's a really, really useful thing. I've got time for one more question, I think. Any more questions? I can't see any hands. Is there one at the back? I can't see. Oh, yeah. Hello. Sorry, I can't see with the light.
Thank you. Okay, just a small one.
Sure.
You showed using GitHub and
Yes.
see that they rely a lot on the pull requests on GitHub and so on. It support GitLab or Bitbucket or other hosting site?
Yeah, great question. So the question was basically, what other Git providers do you support? That's a great question. I should have talked about this before, and I apologize. So today, out of the box, we support GitHub, GitHub Enterprise, Bitbucket Cloud, and Bitbucket Server. Bitbucket Server's still being polished. I think it works fine, but we're still testing it a little bit. There's some support for GitLab, but there's support for Gittier. Gittier is another open source Git provider. I personally really like Gittier because it's kind of really small. It's written in Golang, which is the cool language these days. And it's really small and lightweight, and it looks and feels just like GitHub, but it's just on-premise and open source. GitLab is close. Like we have a bunch of code for GitLab. It's just not quite working yet, but we're hoping to get that working fairly soon. I mean, basically, you want to support all reasonably popular or popular Git providers. And today, we definitely support GitHub and GitHub Enterprise. Bitbucket Cloud is working rock solid. Bitbucket Server is almost there. Gittier is one bug away from being awesome, and then GitLab is soon. But so yes, soon we'll support them all. And we support issue tracking for the Git providers. All have issue trackers built in, and then we support Jira as well for issue tracking. Oh, that's the point. I didn't show you the release. I've just remembered. I meant to show you the release we've just done. If I go back to this app, I never even finished my demo. What was I thinking? If I go to the releases, do you remember we did the second release? There we go. This is 002 that we did of that release. And notice the changelog, it links to the issues. So we've shown that issue 1 is fixed. And also notice on issue 1, we comment on the issues to say that this issue is now fixed in staging because we know when issues go to staging, right? Because we're doing CI and CD. And then we link to the release notes. So that's the release notes of version 2. So if I open that in a new window, we'll see there's the release notes if you want to look at the release notes. And then there's a link to the app if you want to try out the app. Oh, it's not quite running yet. I might be low on resources. But yes, any minute now it'll be running. So yes, so we do feedback on the issues as well, which is kind of cool. What we're hoping to do fairly soon, because we know when the issues get to staging or get to production, we kind of know, we know all of the data for doing things like mean time to recovery and so forth. So we're hoping to do much more tooling around giving you more insight into what's your mean time to recovery. When a bug is raised, how long does it take before that bug gets to production, which is a really useful metric for teams. Any more questions? I think we're almost out of time. No? Can't see anybody. Okay, well, thank you very much for coming. Enjoy the conference. Thank you. Try Jenkins X.